In this video, we're going to take a look at how to solve quadratics. So we've partially done the steps to get to this point where we factored quadratics. So we factored quadratics in the form ax squared plus bx plus c. So we took that standard form and then we factored it using decomposition. So what we want to do now is we want to just write these in factored form and then we'll build off that. So let's take our equations here. I'm creating an equation rather than an expression with the y equals this time, but otherwise we're going to do it all the same. So we will decompose this, multiply our first and last terms, and get 18. So we're looking for two numbers that multiply to 18, add to 9 to rewrite that middle term. And that would be 6 and 3. So plus 6x plus 3x. And then the plus 18. Factor the first pair and the second pair. We're doing the factor by grouping. X plus 6. Bring down the plus. 3 is the common factor. X plus 6. And then again, we have a common factor of x plus 6. We got y equals x plus 6, x plus 3. So there, we've factored it. Let's do the next one. In this case, we have a term in front, an a value. You could do this one using the shortcut method if you figured it out, but if you haven't, again, decomposition will always work for you. So we're going to multiply our first and last coefficients, so we get negative 40. So we need two numbers that are going to multiply to negative 40, add to negative 3. So we're looking at 5 and 8, specifically negative 8, positive 5. So we have 10x squared minus 8x plus 5x minus 4. Again, you can put those terms in the opposite order. You'll end up with the same result, just in the opposite order. Common factor here is 2 and x. We're left with 5x minus 4. And then over here, common factor is just 1, so plus 1, 5x minus 4. And then again, we have this common factor of 5x minus 4. 5x minus 4, and then 2x plus 1. So there are our equations. Now, when we want to solve these equations, what we're looking for in general is the zeros, roots, or x-intercepts. So to solve these, we're going to set the y equal to 0 when we have our x-intercepts. If I draw a quick little sketch here of a parabola, our x-intercepts occur when the y value on the y-axis is 0. So we want to solve these for 0. Well, we know the zeros of the first one, but let's actually show how and why those become negative 6 and negative 3. So we set y equal to 0. And we have x plus 6 times x plus 3. So this whole expression has to equal 0. As the tip says, anything multiplied by 0 equals 0. So x plus 6 equals 0, or x plus 3 equals 0. If x plus 6 is 0, then it'll be 0 times whatever, and the whole thing is 0. Or if x plus 3 is 0, then the whole thing is 0 as well. So it's one of these two things. So there's two solutions here. And in this case, we get x minus 6, or moving the 3 over to the other side, x minus 3. So that's why those signs change when those come out of the brackets, is because they're the actual solutions to this being equal to 0 or that being equal to 0. So that we can do normally without these extra steps, but here it's not so easy because now we have a value in front of the x. This isn't an a value, this is a value in front of the x. So let's take a look at the solution here. 0 equals 5x minus 4 and 2x plus 1. So either this or this equals 0. So 5x minus 4 equals 0, or 2x plus 1 equals 0. one or the other will equal 0. Solving this, 5x equals positive 4, x equals 4 over 5. That is 1, 0. Or, solving this one, 2x equals negative 1, x equals negative 1 over 2. There are my two zeros at 4 over 5 and negative 1 over 2. So all we're doing after we've factored to find the zeros is setting the equation equal to 0 and then each individual portion equal to 0. Let's take a look at some of these special cases for factoring for some review and a couple of special situations. In the first one, x squared plus 6x. There's no c value. This one is easier to factor. You do not have to make a trinomial because what's the first thing we should look for? A common factor. And if we look for a common factor, we'll get x and leaves us with x and x plus 6. So now when we want to solve it, we set it equal to 0. So either x is 0 or x plus 6 is 0. So x equals 0 or x plus 6 equals 0, leaving us with x equals negative 6. There are the two zeros, 0 and negative 6. In the next case, I have x squared minus 9. X squared is a perfect square, 9 is a perfect square, and it's a difference of them. This is a difference of squares. So this one easily factors down to x plus 3, x minus 3. Set it equal to 0. And when we solve that, we get x plus 3 equals 0, or x equals negative 3, or x minus 3 equals 0, x equals positive 3. So there's my two zeros in that case. In the next one, what do we notice about 2, 18, and 36? They all have a common factor of the negative 2. So let's factor that out. Negative 2, we're left with x squared minus 9x minus 18. Sorry, plus 9x plus 18. And saving us some time, if you go back up to the very first question, way up here, we've already factored that. So we get y equals negative 2, x plus 6, x plus 3. And just like before, even with the a value of 2 there, we still have the same zeros. It's still 0 equals negative 2, x plus 6, or x plus 3. This or this equals 0. This is irrelevant because we're multiplying that by 0 and it goes away. So it's either x plus 6 equals 0 or x plus 3 equals 0, and we get our x negative 6 or x is negative 3. So even with the a value, it doesn't change it. And then our last one here, well, this is a little different because we don't have a y, but we have this 14 on the wrong side of the equation. So we just move it over. So all we got to do in a situation like this is take the 14 and subtract it from both sides. Like that. And now we look for two numbers that will multiply to 14 and add to negative 5. That's going to be negative 7x and positive 2x minus 14. Factoring by grouping, we're going to get x, and then be left with x minus 7, and then plus 2, x minus 7, and then finally x minus 7, x plus 2. So, solving that, x equals positive 7 or x equals negative 2. And in these ones here, you don't have to do the extra step like this. If you can just look and see, it's just these ones like this where you have to do that extra step to make sure you get the proper fraction going. So let's take a look at one of the uses of this. And so sometimes when we're solving problems, all the cases we've looked at, we've been solving for the zeros. But sometimes we don't want to find the zeros. We want to find at a given value. So in general, I'll do this kind of separate down to the bottom here. If we have our quadratic and we've been solving that, then we've been looking for these zero values. We've been looking for when y equals 0. But what if we want to know when y is, what the x values are, when y is -3? What are those x values right there? This is still doable, and we're going to look at that in the example. So we're solving for not the 0. So in this case here, we got Johnny throwing a ball off the roof of his shed. The height of the ball in feet is given by the equation h equals -5t squared plus 17t plus 12, where t is in seconds. What time does the ball reach 24 feet above the ground? So if I do a quick little sketch of this, we're shooting somewhere 12 feet off the ground. It's negative, so it's opening upwards. So we're going to have a graph looking something like this, of some sort. This part over here is irrelevant, and anything after the 0 is irrelevant. This is the real situation that's going on from 0 seconds until whatever that point is where it hits the ground. And so we want to know when does the ball reach the ground. In this case here, from our graph, we'll know that it's only going to be a single time that it hits the ground because it was thrown off the roof at 0 seconds, so it would hit at negatives time, which is not possible. So let's solve this. H equals -5t squared plus 17t plus 12. We're going to multiply -5 by 12. That's going to give us -60. We need two numbers that multiply to -60, add to +17. Well, that's going to be 20 and -3. So h equals -5t squared plus 20t minus 3t plus 12. Continuing this on, h equals common factor of -5t. And then we're left with t minus 4. Common factor in the next one, -3. We're left with t minus 4. Notice I factored the negative out of here because it was otherwise we would have got this in the wrong order and we would have had that extra negative. So, works out when we take out the negative. Now, factoring out the t minus 4 and then -5t minus 3. We can now find our zeros by setting this equal to 0. And then we have t minus 4 equals 0 or -5t minus 3 equals 0. T minus 4 becomes t equals 4. So at 4 seconds, or solving this one, -5t equals -3. T equals or +3, sorry, and then -3/5 is the final result there. This one here is inadmissible. Why? Because we can't have negative time in our situation here. So that's this point back here. We don't want that. And so t equals 4. That's when the ball reaches the ground. The ball hits the ground at 4 seconds.